is learn to solve equations as we're getting ready for the testing coming up next week. Ms. McShannon and I felt that this is one of the areas that we really need to make sure that you understand. So we're going to do kind of an abbreviated. This should be 2 lessons in and of itself, but we're going to do all 4 just to make sure you guys have exposure to all 4 operations, because this is our last lesson before our end of year testing. Okay? Now, it is important to understand some of the properties that work in what we're using in order to be able to solve equations. One of the first ones is what we call the subtraction property of equality. So given the name of it, should help us out. It says if you do what? Subtract, makes sense, right? If I subtract the same amount, the same number from each side of an equation, the 2 sides remain, what's the math term for that? Equal. So if I subtract the same amount from both sides of an equation, then the equation remains equal. In other words, it still has the same amount on both sides. So what do I mean by this? Let's take an example. If I have 10 plus 4 is 14, but I'm going to subtract the same amount from both sides. So I'm going to subtract 4 from this side and subtract 4 from this side. Let's see what happens. 4 and negative 4 are opposites. If I put opposites together, what do I get? What's the result? 0. Because they're the same distance from 0. I put them together, it comes back to 0, right? Is everybody okay with that? So this becomes 0. They cancel each other out. So on this side, I just have 10. Is everybody okay with that so far? Good. Equals, what's 14 minus 4? Does 10 equal 10? So by taking 4 away from both sides, did my equation stay equal? Because what's 10 plus 4? 14 equal 14? Taking 4 away, does 10 equal 10? Make sense? So let's look at another one. What if I have a plus 8 equals 24? So some variable. Does everybody know, who doesn't know what a variable is at this point? Raise your hand. Be honest, please. Okay, let's put this definition down. We've got a little bit of room here. So a variable is a letter or symbol that represents an unknown number or quantity. So basically, it's just something that's holding a place for a number I know is there. I just don't know what that number is. You'll be able to substitute once I find out what that number is, and then you'll be able to know. Okay? So in this case, I'm adding 8. So the opposite of adding 8 would be subtracting 8. So I'm going to subtract 8. But again, equality, I have to do it to both sides, right? So 8 and negative 8 are opposites, meaning if I put them together, I get 0. So on this side, I just have a. 24 minus 8 is 16. Okay? Now here's the beauty of math. Unlike language arts or social studies, where you put in an answer that you think is right, and then you have to wait for the teacher to tell you if you did it right, math, you can know yourself, because all I have to do is now say, okay, I'm going to put 16 back in for my a. So if I do 16 plus 8 equals 24, what does 16 plus 8 equal? 24. So now I know I got it right, because 24 equals 24. The beauty of math. If you're willing to invest the time, you can know that you are correct. Emily? Hold that thought. We'll get to it. But right now, the concept I want you to understand is if I subtract the same amount from both sides, my equation stays equal. You go with that part? Okay. So the next part is what we'll get to, haven't we? So you're just about 3 steps ahead of me. Yes, Micah.
So next time where we do a work on our homework, what's our homework for next week?
I'll take it if you finish it in class. No, because you're supposed to be copying this down, Micah.
I'm just saying next time you can you?
I have hands. Okay, addition property of equality. If I what the same number, what do you think I'm doing? If it's addition property of equality, I'm going to add the same number to each side of the equation. The two sides remain equal. Makes sense, right? So let's take a look. So if I have 20 minus 6, but instead of subtracting 6, I'm going to use the addition property of equality and add 6 to both sides. 6 and negative 6 are opposites, meaning when I put them together, I get 0. So on this side, I just have 20. 14 plus 6 is 20. Does 20 equal 20? Yeah. So it stayed equal. Yes?
How do you have like the 20 on the first one?
What do you mean?
So you got 20 minus 6 and then plus 6.
Right. Because I was taking 6 away, but then instead I added the 6 back. So I just came back to the 20.
But 20 plus 6.
But no, I was subtracting. Madison, I was subtracting 6.
Oh, I thought you were adding 6. I didn't know I could.
No, initially I was subtracting 6. Make sense? Oh, I did move it. Man, I'm good. Talk about magic. Okay, let's try this algebraically. Oh, Kaylee? I will. I think it actually makes more sense to explain it algebraically, and then when you see the substitution, then it should hopefully click better. So let's look at it using variable. So if I had x minus 8 equals 32, oh, sorry, helps to write the number I say, 32. But instead of subtracting 8, I'm going to add 8. So I'm going to, but I have to do that to both sides. Remember that you call it, the addition property of equality says I have to do that to both sides with the same number, right? So now I have 8 and negative 8. So those opposites make 0. So on this side, all I have left is x, right? 32 plus 8 is 40. So here's why I hope it'll make more sense to you. So watch this, Kaylee. So now if I put that 40 back into the original, and I now say 40 minus 8 is 32. What do I get when I take 40 minus 8? Does 32 equal 32? Then my variable did equal 40. Heavenly? Guys, quiet. Micah. Yes, and we'll get, again, you're about 3 steps ahead of me still. We'll get to that part when we start solving them. Right now, we're just building up the basis for why these properties work, okay? So this next part should help you to process this, okay? Don't worry, the next step is designed to help you out, Kaylee. So we can use inverse operations to solve equations. Inverse operations basically undo each other. So, for example, to solve an addition equation, I'm going to subtract. To solve a multiplication equation, I'm going to divide. Okay? The entire major concept for today, guys, is get my variable by itself. We want him to be alone. Okay? Once the variable is by itself, then we know whatever's on the other side is what it equals. Okay? Now, to help Kaylee visualize what's happening, that's what this next part is for. So if I think about my equation as a scale, what's important about a scale? If my scale is level like this, what does that mean? It's equal. It has the same amount on both sides, right? Is everybody okay with that? So if a scale is balanced, it means that it has the same amounts on both sides, right? So we can think of the center as being our equal sign. So if it's an equation, the center is actually an equal sign. So let's put an equal sign inside that triangle. Okay? Now we're going to draw a dotted line through the center to help us visualize the two sides of our scale. Okay? Now let's do a problem. In our problem, I have x plus 6 on one side. On my other side, I have 10. Now, the whole idea, again, is to get our variable by itself. Right now, I've added 6 to it, right? So if I want to get my variable by itself, what do I have to do? Then it's going to have 12. If I do minus 6, now that's going to be 0, right? Because 6 and negative 6 are opposites, meaning they come to 0. But if I only took it off one side, what's going to happen to my scale? It's going to be unbalanced, right? But what if I take that same amount off of this side? It's going to go back to balance, right? So on this side, by taking the opposites, I just have x left on this side. On this side, I now have 10 minus 6, so how much is that? I just solved my equation. Okay? Now, guys, let me show you something, and I'll be honest. I have literally worked on this for years. The first couple of years I taught equations to my students, I failed miserably as a teacher. It did stink. It stunk really bad. I racked my brains trying to figure out why what I thought was so intuitive was not working for my 6th grade students teaching this for the first time. And actually looking at their work and talking with them, I figured out what it was. So this process has been developed to try to help you be successful in doing this. There are 4 steps to it. So in this little space right here, for those of you with big handwriting, I apologize. You need to shrink your handwriting to get it all in here. But it's not hard. Step 1, I need to circle the variable. Step 2, I'm going to draw a line through the equal sign. And these are the 2 steps that I added in to help people visualize what's happening. Okay? So once it doesn't have to be perfectly straight. Does not. Step 3 is where we start getting into the math of it. And here's why we did the first 2. Find the number that is with the variable. So the whole idea behind the circling and the line is to help you get focused on the side of the equation that I need to be working on. It says find the number with the variable. Okay? Step 4, relatively easy, but the most critical point, and this is where all these properties we've been talking about come in. So I'm going to do the opposite operation with that number on both sides of the equation. So you're going to locate the number, you're going to figure out what operation it is, and then you're going to do that operation with that number on both sides of our equation. So the whole idea between the subtraction property of equality and the addition property of equality is we're rearranging all the numbers to get our variable by itself. And we do that with inverse operations. So let's take our example. In our example, we have x plus 6 equals 10. So step 1, I just circle the variable. Is that hard for anybody? Do what? So if you wrote it in the box, you can use it, do this above. It doesn't take much. I need to draw a line through my equal sign. Is that difficult for anybody? Am I asking you to do a whole lot of work here? No, not really. Now, here's why we did this. What number is with my variable at this point? 6. Is there anybody who doesn't understand that the 6 is with the variable. So everybody's good? What operation is happening? So here's where we have to use our inverse. So what's the opposite of adding? So I'm going to subtract 6, but I have to do that on both sides of the equation. Because if I didn't, it would go out of balance. Make sense? So I now have 6 and negative 6. Those are opposites, meaning they equal 0. So I can just cross them off because they've gone away. So on this side of my equation, all I have left is x. On the other side, if I do 10 minus 6, I get 4. And now here's the beauty of math. I can check to make sure I'm right. I put the 4 in for the x. I say 4 plus 6 equals 10. What does 4 plus 6 equal? I now know, beyond a reason, any doubt, I've got this right. 10 equals 10. Kaylee. Correct. You have to have the balance in math. Otherwise, your numbers are going to be anywhere. But if you keep it balanced, we can do anything I want to either side of the equation. If I do the same thing, it's going to stay equal. Okay? Everybody good so far? Okay, let's turn the page. We're going to do a few more examples using our scale. So let's start off with our equal sign and our line. And we'll rewrite this. I now have x plus 4 on this side. I have 10 on this side. So what would be the opposite of adding 4? Kaylee? Subtracting 4. So, but remember, to keep my scale balanced, I have to do it on both sides. I now have 4 and negative 4. Those are opposites, meaning that they equal 0. So those cross off. On this side, I just have x. 10 minus 4 is, I've now solved it. Okay? Showing our work. X plus 4 equals 10. Here's my variable, my line through the equal sign. Literally should take you half of a second to do that, guys. I shouldn't see anybody fighting me about doing it. I think so too. But the scale helps people visualize and understand why. We're not going to do the scale past, well, we will when we do division and subtract and multiplication. But once you guys get the concept, I don't expect you to do the scales. Okay? What's the opposite of adding 4? Do that to both sides. Opposites go away. I just have x. 10 minus 4 equals 6. Now I can check my answer. 6 plus 4 equals 10. 6 plus 4 is 10. 10 equals 10. Check. I got it right. I would say let's go, but I've been accused a time or two of going too quickly for you guys. So since I don't have Ms. McShan here to keep me held back today, I got to do some self-regulation. Yes, Micah? I prefer no wall, but what do you think? It does seem a lot quieter in here today, I have to admit. Okay, guys, let's do our next one. Again, let's put our equal sign in and draw our wall. On this side, instead of adding, I'm actually subtracting this time from my variable. So what would be the opposite of subtracting 3? So I'm going to do it, but remember, to keep my scale equal, I have to do it on both sides of it, correct? So a negative 3 and a positive 3, those are, they equal 0 because they are what? Opposites. So those opposites make 0. So I just have x on this side. 6 plus 3 is 9. So algebraically, x minus 3 equals 6. Here's my variable and my line through the equal sign. Emily? No, because the whole idea on this is I'm solving for a variable. Yep. That's what we mean when we solve equations. We're trying to figure out what the missing number is. So where's my variable? What number is with it? Ian? What number is with my variable? 3. What's the operation? Do what? Did you say addition? So what's the opposite of subtraction? Addition. So I'm adding 3 to both sides. -3 and 3 are opposites, meaning they cross each other out. They equal 0. So I just have x left on this side. 6 plus 3 is 9. Let's check. Substitute in 9 minus 3 equals 6. 9 minus 3 is 6. 6 equals 6. We got it right. How you guys feeling on these? Feel pretty intuitive? Okay. Now, the next one is designed to show you it doesn't matter what the order is. My variable can come first, it comes second. My variable could be on the right side instead of the left side. It doesn't matter. That's part of the reason we draw the line and circle the variable, though, is if they move that variable for you, you're still able to locate it and figure out where it is. So our basis is the same. We have our equals and our line to divide our scale. On this side, I have 2 plus x. On this side, I have 7. The opposite of adding 2 is subtracting 2. I have to do it to both sides to keep my scale equal. 2 and minus 2 are opposites, meaning they cross out. That means I just have x. 7 minus 2 is. Okay? So again, 2 plus x equals 7. Here's my variable and my line. What number is with my variable, Maddie? Which one of you goes by Maddie? Which one goes by Madison? Exactly.
I mean, sometimes it's you and this big chair, you're always talking like you're
I call you Madison very consistently. I have plenty of proof of it on the videos. Maddie? What number is with my variable? 2. It's not hard, right? You got the wall, you got the circle. What's the operation? What's happening? So the opposite would be subtract. So I'm going to subtract 2 on both sides. 2 and -2 are opposites, meaning they equal 0, they go away. On this side, I now have just my x. 7 minus 2 is 5. I can now substitute just to verify. 2 plus 5 is 7. 2 plus 5 is 7. Does 7 equal 7? Yeah, we got it. Okay. Do one more here. Our equal sign in our line. On this side, I have x minus 3. On this side, I have 2. So what's the opposite of subtracting 3? Addition. So I'm going to add 3. To keep my scale equal, I do it on both sides. -3 and 3 are opposites, meaning they become 0. So I can cross those out. All I have left down on that side is my x. 2 plus 3 is 5. So let's show it algebraically. X minus 3 equals 2. Here's my variable and my line. What is the opposite of subtracting 3? If I do it to one side, have to do it to the other. 3 and -3 are opposites, so they cross out. I just have x left on this side. 2 plus 3 is 5. Substitute in to make sure I got the answer right. 5 minus 3 equals 2. 5 minus 3 equals 2. Does 2 equal 2? Yes. Ava? It's still a line. Because after 3 periods, I'm used to drawing the solid line because I'm teaching how to do it with the equations. But I know that in the actual directions it says a dotted line, so occasionally I remember and do it right. On occasion. First period I did it right every time. Okay, our next one, let's do this in a word problem. So Ruben and Tariq have 245 downloaded minutes of music. If Ruben has 132 minutes, how many belong to Tariq? So there's our question. Write and solve an addition equation. So they were very specific on what we need to do. to determine how many minutes belong to Tariq. What property did we use? So there's a second question in this. Okay? So make sure we do both of those. Now, the first question you need to ask yourself, especially in word problems like this, is what is it I don't know? Because I need to identify and define a variable. Alyssa? Okay, so what do I want to use for a variable on that? I would avoid t because it looks a lot like a plus sign if you're not careful. I prefer x, honestly. Okay, so x equals, and don't forget to fully identify your variable, the number of minutes of music for Tariq. So with a full identification of my variable, it should make the rest of this easier to do. Now the second part is they want an addition equation. So that's saying I'm starting at 245 and 5/10, and it equals what Ruben had, which was 132, plus what Tariq had, which is x. We just made it our variable, right? So here's the cool thing. Our process is always going to be the same. I'm going to circle my variable, draw my line through the equal sign. What number is with my variable? 132. What operation's happening? Addition. So the opposite will be subtract. So I need to subtract 132 from both sides. Because anything I do to one side, I have to do to the other. So 132 and negative 132 are opposites. They go away, so I can just cross them out. Again, that's the whole purpose of everything we're doing today, because I want x by itself on this side. Now on the other side, now I need to remember the rules for subtracting decimals. What's the rule? Line up my decimal place. So fortunately, it had the same place value, so they're already lined up. So I just need to add a decimal and a 0 to my bottom number. Okay? Now I just subtract. 5 minus 0 is 5. My decimal comes straight down. Again, a difference between multiplying. 5 minus 2 is 3. 4 minus 3 is 1. 2 minus 1 is 1. So what does x equal? Pretty easy, right? Now, it's a word problem, so let's answer in a full sentence. What is it we were answering? So Tariq has 113 and 5/10 minutes of downloaded music. Was that the only thing we had to answer? No, what else did we have to answer? What property did we use, guys? We did? So I added the same amount to both sides? So we used the subtraction property of equality. $113 minutes? That ain't much music.
Yeah, that's like 100 songs. No, not like 100. No, that's like 50 songs.
That's like 30 songs.
That's like
Average song is 3 to 4 minutes. Average song is 3 to 4 minutes. If I divide that number by 4,
talking about rap music, it's like 2 minutes.
no. Okay, guys. Is this all making sense so far? Okay. Unfortunately, we have a lot of very intelligent students who like to do this stuff in their head and think I'm asking too much work by circling and doing a line. So your numbers on this aren't the greatest, because if we did the numbers easy, I have too many of you who would not show your work. But if you will show your work, this is still easy to do, guys. What do I mean by that? Watch this first one. Circle my variable, draw my line. Avonlea? No, you don't have to do the scale and weight things. This is just the 4-step process. Circle your variable, draw your line. What is the opposite of adding 3 8/10? I do that to both sides. So this side, they're now crossed out because those are opposites. So on this side, all I have left is x. How do I subtract decimals? Line up my decimals. So 3 minus 8 I can't do, so I'm going to have to borrow from the 4. 13 minus 8 gives me a 5. My decimal comes straight down. 3 minus 3 is 0. So x equals 5/10. If you want to check yourself just to make sure, 0 and 5/10 plus 3 and 8/10 equals 4 and 3/10. Add those two together. I get 3, carry the 1. 4 and 3/10 equals 4 and 3/10. Now I know I'm right. Questions on this piece of the homework? Yeah, this is homework. Do you see this right here? Are you paying attention to the board? Oh, so you don't pay attention to me, Micah? You literally just said you were so focused on your paper you didn't see that it's right there.
I wasn't focused on the background where it said.
Why aren't you focusing in class? You just said you weren't focused.
I was focusing on
Micah. Guys, let's turn the page. Just for the record, I was just giving Micah a hard time. He's doing well today.
Where are you using names on stereo?
Okay. Go ahead. Now we're going to talk about multiplication. No, Aaron. Now we're going to talk about multiplying and dividing. The idea is basically the same, guys. If I think about x as being the amount that is hidden inside of each of these coffee cups, and we know that the amount hidden in all three is equal to 12, how many marbles are hidden in each? Okay? So that's what we're trying to figure out. So I know I have these 3 cups. I know I have 12 marbles. But now I need to figure out how much is in each of those cups. Well, if I have a model, the easy way to do it is to say, okay, well, let me take the marbles. I'll put 1 into this cup. Then I'll put 1 into this cup. Then I'll put 1 into this cup. Then I'll go back to the first cup again, and I'll just keep repeating that process until I have placed all of the marbles into a cup. Groupings. Okay, so how many marbles ended up in each cup? 4. Does that make sense to everybody? So our answer is we have 4 marbles in each cup. Okay, I'm not going to have you guys work with partners because we're getting close on time. I want to run through this. Yes, Emily? We're about to show that. Okay? So if I have an equation, 4x equals 8, our process is going to be the same. It's why I like this process, guys. Once you understand the process, it works for any equation. So I'm going to circle my variable and draw my line. What number is with my variable? What's the operation if I write the number beside a variable? Multiplication. So my opposite is division. So I'm going to divide by that number. Okay? 4 divided by 4 is 1. 1 times x is x. Does it matter what number I multiply 1 by? What do I get? That number. There's actually a property for that, so we're going to use this space right here. This is called the multiplicative identity property of 1. Okay? Here is the property. What it says is any number multiplied by 1 equals that number. It doesn't matter what the number is. That one actually even works for 0. 0 times 1 is still 0. So I'll give you guys a second to write that one down. So our multiplicative identity property of 1 is what we're using on both the multiplication and division problems. Because in both cases, my whole idea is get the number times the variable to be 1. Because once I'm down to that, whatever's on the other side is what that variable equals. So in this case, I now have 1 times x. 1 times x equals what? He was solving it. 1 times x is x. 8 divided by 4 is 2. Okay? So, again, we can always check our answer to be sure. So I substitute the 2 into the original expression, original equation. 4 times 2 is 8. What's 4 times 2? 8 equals 8. Check. We got our answer correct. Making sense so far? Okay, let's do another one. I have 3x equals 9. Here's my variable. Draw my wall. Luna, what number's with my variable? X is my variable. What number's with it? 3. Good. What is the operation when I write them side by side? Maddie? What's the operation when I write the number right beside the variable? Multiplication. So the opposite would be division. So I now need to divide both sides by 3. 3 divided by 3 is 1. 1 times x is x, multiplicative identity property of 1. 9 divided by 3 is 3. So let's substitute back into our original equation. 3 times 3 equals 9. 9 equals 9. Check. We got it right. Okay? Actually, I think we have time to finish one more before lunch. Okay? 7x is 14. Here's my variable on my wall. What is the opposite of multiplying by 7? Dividing by 7. Again, to keep my equation equal, I must do that to both sides. So 7 divided by 7 gives me what? 0. Madison. 7 divided by 7 is 0? Yes. 1 times x is x. 14 divided by 7 is 2. Let's do our check. 7 times 2 is 14. 14 is 14. Math is awesome. I got it right. Okay, let's finish after lunch. Guys, recording's back on. Going on the next page. Okay, now we're going to talk about division. I'll be honest, division models of any of the models really kind of drive me the craziest. Mostly because they're the most difficult to put together. A lot of it depends on how you're actually approaching the division problem. So I'm just going to show you this. I don't expect you to do these models, just like I don't expect the scale on any of these. But I at least want to show you what's happening. So we have 3 teachers who went to a conference. They shared the cost of gasoline G equally. Each teacher paid $38.50. Draw a bar diagram to find the total cost of gasoline. So the bar diagram is this piece here. When we're doing a division model, whatever we're dividing up is what goes on the top. So in this case, what are we dividing up? The total cost of the gasoline, which we are representing with the variable G. Okay? How are we dividing this? Into what? 3. And how much is each piece? So each teacher paid $38.50. We had 3 teachers. So really, what I'm doing is I prefer to go ahead and draw all the boxes in. So all 3 of them were $38.50. So how do I find out what my total is? Add them, or since I have repeated addition, we call that Multiply. So I can multiply 3850 by 3. I have 2 decimal places. Now I forget them. 0, 15, 24, 25, 9, 11. Once I get to the end, now I put my 2 decimal places back into the problem. Starting from the right-hand side, because I had units on this, I'll include the units. So how much did they spend total? Sadie, how much was it? Good job. So the total cost was $115.50. I don't know why the T didn't come out. Does that make sense? Krista? Did you write any of it down? Do you have it all written down, including the full sentence answer? Krista? Don't make me come look at your paper. Okay, Sylvia has completed 8 math exercises E. This is 1/4 of the assignment. How many exercises were assigned? So really we're talking about the total number of exercises. So I prefer to do a bracket like that, showing what it is. This is E. How much of it has she done? 1/4. So if I divide my bar into 4s, how much was each 4th? How many did she do? 8. So I have 4 of them, meaning how many exercises did she do? Jonah, please put that away and focus. What did you say, Madison? 32. So Sylvia had 32 exercises in the assignment. So from a modeling perspective, does that help you guys see what is happening in these? Whatever it is I have, that's my big piece, and then I'm dividing it into however they want. If it's 1/4, 1/3, that makes the modeling easier. It's when you start getting into 2/3 and 5/7, then the models become really obnoxious. Yes, ma'am.
What's the green rectangle?
That's the whole. That's the total number of exercises.
No, what's the number?
The number line is if I did it by intervals. So really what the way they've done it is actually what we call a double number line. So I would start out and I would say, okay, here's the total exercises, always starting at 0. Okay, this is the exercises. This is what Sylvia completed. So how many of them did she do? How many exercises did they have? 1/4. How many was it? 8. So the next part would be 1/2 or 16. 3/4, 24, 4/4 or 1, 32. Most of you, I don't think that way, but it's just showing you could do it that way if you wanted to. Okay? Do what? JJ? Okay, sure? Okay, so let's talk about how we go through this process again. This should look really familiar. If a scale is a balance, that means that it has what kind of amounts on both sides? Equal. Equal amounts on both sides, right? So we can think of the center of our scale, the fulcrum, as being our equal sign, just like in our last set of notes. Okay, so let's go ahead and draw the equal sign in the triangle. Now we did the dotted line, I did the solid line again. But the equation we're going to do now is 2x equals 6. But it's the same basic concept. Okay? On this side, I have 2x's. So what's the opposite of multiplying by 2? Dividing by 2. But if I only did it on one side, what would happen to my scale? Be unbalanced. But if I do the same thing to this side, now we've restored the balance to the scale. So what is 2 divided by 2? 1. Balance of the force. So now on this side, 1 times x, I just have x. Identity, multiplicative identity property of 1. 1 times any number is that number. So now I know it's just x. 6 divided by 2 is 3. So if I were to do this mathematically, I would just say 2x equals 6, draw my circle and my line. What number is with my variable? 2. The operation is? So the opposite would be division. So I'm going to have to divide both sides by 2. I now have 2 over 2. That becomes 1s. 1 times x equals x. 6 divided by 2 is 3. And again, if you're ever unsure, you can always just check our answer. You write as divided by, either way. I just like the fraction because I really like reductions. I like to make the math as easy as I can. If I have it as a fraction, then that reduction looks easier to me. Okay, so again, let's just check real quick. So I have 2 times 3 equals 6, because I said that the x was 3. 6 equals 6. Check, we got the answer right. Okay? Now, we're going to do the same thing, but now instead of 2x, I'm going to use 1/2 x equals 6. So on this side, I now have 1/2 x. On my other side, I have 6. If I write them side by side, what am I doing? Multiplying. The opposite of multiplying by 1/2 would be dividing by 1/2. So I'm going to divide by 1/2. But here's where we get into a slight issue. Because can I actually divide fractions? No. So 1/2 divided by 1/2 is actually what? How do I solve this? Good. I keep 1/2, change the times, flip to 2 over 1. So now I just have 2's on top and bottom. That's just 1 over 1 or 1. So here's where I'm going to give you guys a quick hint. If I am multiplying by a fraction rather than dividing by it, I can actually just go straight in to this step and multiply by the inverse. Okay? For those of you who understand what I just said, please do that. If you don't understand what I just did, go through the whole process of dividing. But this is going to make it a lot quicker if instead of dividing by a fraction, I multiply by the inverse. Because on this side, now I just have 6 over 1 times 2 over 1 is 12 over 1, which equals 12. So the bottom line is x equals 12. Let's go through this mathematically so that you guys can see what we just did. So if I have 1/2 x equals 6, here's my variable. What number's with it? X is the variable. What number's with it? 1/2. So because I'm multiplying by a fraction, instead of dividing, I'm going to multiply by its inverse, which is the same as dividing. Is everybody okay with that? Okay. So I'm going to multiply by its inverse, 2 over 1. So on this side, I also need to multiply by its inverse. We do that same thing to both sides. That's also why it's important to do it right away to make sure you keep track of the correct numbers. Make sense? So on this side, I now have 2's top and bottom. That becomes 1. 1 times x is x. Multiplying fractions, I need to make that into an improper fraction. So now I have 6 times 2 is 12. 12 over 1 equals 12. So let's do our check. If I do 1/2 times 12 equals 6. 1/2 times 12 means I put this over 1. I can do 1 reduction, gives me divide both those by 2. So I now have 1 times 6 is 6. 6 over 1 equals 6, which equals 6. So it actually worked out. Are you staying up? How are you guys feeling on this? Is it making sense to you? Okay, let's turn the page. We just got a couple more, But this one, I actually want you guys to do by yourself. So solve this. I'll give you a hint. Rewriting it will make it easier for you to solve rather than trying to work on it from there. Stop talking. Okay, this one, again, if you rewrite it, it's going to be a little bit easier. I have 2/3 x equals 4. Here's my variable. There's my line. What number is with it? 2/3. So the opposite of multiplying by 2/3 is multiplying by 3/2. So I multiply both sides by 3/2. Also, I highly recommend writing it down immediately on both sides. Don't do all the work on one side and go over, because you might lose track of what you actually did. As soon as you change something on one side, do it immediately to the other side of your wall. Here's why I love this, because now these just go away. Those all become 1s. So I just have x. To do a whole number times a improper fraction, I turn this into an improper fraction as well. I have a 2 and a 4 I can reduce. 2 times 3 gives me 6. 6/1 is 6. So now I can check it real quick just to make sure I did it right. 2/3 times 6 equals 4. Put this over 1. I have 1 reduction. 2 times 2 is 4. 4/1. So I end up with 4 equals 4. Yes? No, that's fine. You don't have to do reduction. Reductions just make the math easier. It's less chances of making a math error if you do the reductions. Because if you don't do reductions, I'm going up to bigger numbers and still having to come back down. But as long as your math skills are solid, you shouldn't have a problem with that. Okay, so we're going to do one last one together. Here's our equal sign. This time I've got the equation x/2 equals 10. So what is the opposite of dividing by 2? Whoever's humming, please stop. Multiplying by 2. So I'm going to multiply both sides by 2. This one, I put over 1. So now that the 2's will go away. So on this side, I just have x. 10 times 2 is 20. Mathematically, x/2 equals 10. Same deal. There's my circle and my line. What's the opposite of dividing by 2? Multiplying by 2. So I multiply both sides by 2. These go away, it just becomes x. 10 times 2 is 20. We can do a quick check. 20 divided by 2 equals 10. 20 divided by 2 is 10. 10 is 10. 10 equals 10. Life is good. Avonlea? No, technically x is 20, because I have to divide it by 2 to get to 10. Yes, Kaylee? Over the next 2 weeks, absolutely. You're also going to have a lot where you're going to need to do a full explanation of your work, not just solve it. Okay? So hopefully you guys will put in the required effort. Let's look at our homework. These aren't bad. Let me just point out a couple of things. First off, on this 6th problem, I start out with a mixed number. If I have a mixed number, what's the first thing I need to do? JJ? Awesome. Turn it into an improper fraction. Guys, all the rest of them are straight up. If I've got a fraction, I multiply by the inverse. This is just a fraction. That means I'm doing what? Multiplying or dividing? Right now I'm dividing, so to get rid of it, I need to multiply. Same thing here. Don't let which side it's on mess you up. Going back to the other page of homework, since this is our recording for everybody. The other ones on this one that could cause a little bit of trouble, really shouldn't be any bad ones. This one, you're going to need to make sure you have a common denominator for number 7. Number 9, again, you have to have a common denominator. Remember, I can do the fraction piece and then the whole number piece when I'm doing mixed numbers. So you have 2 choices. You can turn the whole thing into an improper fraction, or you can do it by pieces. I highly recommend doing it by pieces. On this one, number 10, don't forget your decimal rules. You have 2 decimal places on one side and only 1 on the other. So you need to make sure you set them up correctly. If I see a whole number, where's my decimal? So that I can line them up. If I have a whole number, where's my decimal so I can line them up? Evanly? On the right side of the number. So you can, if you want, I'll give you a hint. That side you can have 9 and 0/10 so that you have something to do with it. Overall, it should be relatively easy. You guys actually have another 3 minutes. If you actually focus, you can at least finish your back page very easily. Good luck.